Hello everyone. So today we will solve this IIT JAM question number 5, which was for 1 mark. And in this question we were given that there is an Michelson interferometer. So what actually is a Michelson interferometer is the laser comes over here and it passes through the beam splitter. So beam splitter, as the name suggests, splits the beam into two parts. One goes to the mirror M1, the other goes to the mirror M2. So, and when they are reflected back from the mirrors M1 and M2, this beam splitter actually recombines both the beams to produce some interference pattern. So now it is also given that in one of the path, a glass cavity is introduced of thickness T, which is equals to 1.3 centimeter. And initially we take it as it is filled with air. That means the refractive index of the medium inside the cavity is 1. And in this condition, or in this case, the interference condition or the path length or the traveled by this beam can be given by, let's say that it is delta x1, which is equal to 2t, since it is filled with air, and we know that it is given by the integral multiple of the wavelength of light which we use, or let's denote it by n naught lambda and give it equation number 1. So n naught is nothing but the n naught or the nth order of the fringe which is being produced, since it is a reference line for us. So we are taking it as n naught. So now this medium or the cavity is being now filled with the medium of refractive index eta. So please note that as soon as a medium is being filled, we can see a change in the fringes which is happening. So we can see the evolution of fringes. So, and it is given that when this medium is introduced, the observer observe the number of, or he counts the number of fringes which are being collapsed, and that number is 472. It is given in the question. So when it is completely filled with when this cavity is completely filled with the medium, at that point, the equation can be given by, or the path difference at that point is delta x2, which is equals to 2 eta t. So please note that now it is 2 eta t because there is a medium through which the light is traveling, and this is n lambda. Since after introducing the medium, the number or the order of fringe has changed, so now we are giving it as n lambda, and it is given in the question that this number on going from the reference to the medium one, or when the cavity is filled with the medium, the number of fringes that have collapsed is 472. And this is number of dark fringes that he has counted, because it is easier to calculate dark. So we give this or denote it as M now. And this you can see from here that this can be calculated using both these equations 1 and 2. So we just simply have to subtract equation number 2 from 1, and we get 2 eta minus 1 t equals to m lambda. Please note that this will be now become n minus n naught. So therefore m lambda. So now we have got nothing to do. We only have to solve for this eta. We have to find the value of this eta, and we can easily calculate it because all the numbers are there. So we have eta minus 1 equals to m lambda upon 2t, which is nothing but 472 into 610 into 10 to the power minus 9 divided by 2 into 1.3 into 10 to the power minus 2. So therefore our eta minus 1 or eta is equals to 0.011 plus 1, which is equals to 1.011. So we have now calculated the refractive index of the medium that was filled inside the cavity in the Michelson interferometer. So in the question, it was given that the dark fringes are moved. So just think over it. What will happen if instead of dark fringes, the observer calculates the number of bright fringes collapsed? So will there be a change in it or not? You have to think over it. And please let us know what will be the answer in that case. So thank you.